Quadratics, page 1. I've chosen a few problems to do on page 1. Basically, you should read this first part up here. It says that when you are trying to solve an equation for x, oftentimes you might be able to put everything on the left so that on the right there's only equals 0. And then once you do that, let's say you've got a bunch of stuff over here, if you can factor this into a couple different binomials, then, and when I say binomial, I mean like x minus 3, something like that, then you can use the null factor law and say, okay, well, if this thing is 0, then it doesn't matter what this is. 0 multiplied this is equal to 0. And same thing, if this is something and this is 0, as long as one of these is 0, you can say that the whole thing is 0. So by factoring it into two or more binomials, then you kind of make it easy to figure out when this polynomial is equal to 0. Okay, and let's try a couple so you can see what that means. Okay, so that we're going to do 1b. Okay, we're going to start with 6x squared plus 2x equals 0. Okay, so there's a one or two specific numbers. If we put into x, it's going to be 0, and obviously one of them is, if you put in 0, it's going to be 0. But how do we figure that in a way so that we don't have to guess? Well, we're going to take 6x squared plus 2x. We're going to factor it. Remember that when you factor, if you if you look at this, you can see, hey, both terms have an x, both terms have a 2, so I'm going to factor out 2x. I'm left with 3x here because 6x squared with 2x factored out is going to leave 3x. Factor out 2x there, that leaves just 1, right, because that is 2x, and I set that equal to 0. Now I can say with the null factor law that if this is equal to 0, or if this is equal to 0, then those two multiplied together are going to be equal to 0. They're not going to be 0 at the same time, but that doesn't matter. If you have 0 times 5, that's still 0, right? It doesn't matter that this is 5. Okay, so let's figure out what are those two possibilities. Well, so we're going to say, well, when is 2x equal to 0? Well, 2x is equal to 0 when x equals to 0. So that's one of the solutions that we had guessed up here. Now what's the harder solution? 3x plus 1 equals 0. Okay, so when 3x plus 1 is equal to 0, this will also be equal to 0. Okay, because it doesn't matter what 2x is then. Now we're just going to use algebra. We subtract 1 from both sides. And I advise you to always write it out like this so you don't make any mistakes in your head. It's really easy to make mistakes in your head doing algebra. Now you're going to divide both sides by 3. And that'll give you x on the left, and it'll give you negative 1/3 on the right. So those are the two solutions. Okay, and now we're going to do, that's the answer there. And then we're going to do I. Same thing's going to happen here. We're going to try to put everything on the left, and as you can see, the right side is not 0 like it was here. This is nice and easy. It's already ready. But this one, we need to move everything to the left. We do that with algebra. So the first thing we're going to do is we're going to subtract 10x from both sides so that we make this side equal to 0. And then on this side we'll have x squared minus 10x plus 21. Now, if we factor this into two binomials, we'll be able to use the null factor law again. So if you remember how to do this, you're going to put x minus something times x minus something is equal to 0, and we don't know what that something is yet. But what we do is we say, okay, well, you know, it's going to be some factor of 21, so it's going to be like 1 and 21. Or it's going to be 3 and 7. And 21 doesn't have too many factors, so we can be pretty sure it's like one of these four. And which one of these combinations adds up to 10? Well, 3 and 7 look like likely suspects, so how about if we put those in first, just as a guess. So 3 times 7 is 21, that's good. I usually put negatives here first just because I can make them easily into positives without erasing, so I usually assume it's negative. Negative 3 times negative 7 is 21. Positive 21, that's true. Negative 3x minus 7x is equal to negative 10x. Hey, that worked out, right? Minus 3x minus 7x is equal to minus 10x. So we guessed correctly. Okay, so now we just need to finish this first binomial. If it's 0, that would make the whole expression 0. Or if the second binomial is 0, that would also make it equal to 0. So that would be x equals, and we're going to add 3 to both sides, right, in algebra. And then we'll get x equals 3. That's one of the solutions. And then we'll add 7 to both sides. And that will give us x equals 7. And that's the other solution. Okay. And now we're going to go down to number 2. And I've chosen J to do for you. So this one's a little bit more complicated because, well, first of all, you have to move everything to the left to put everything equal to 0, just like we did above. Except this time you can see we have to move a couple things. So let's see, we're going to subtract 11x from both sides. And we're going to subtract 15 from both sides. And if we do that, we can see that the right side goes to 0. Right? And the left side is going to be 12x squared minus 11x minus 15. And this is much more complicated to factor because it's got a non-1 number here, right? Now, if they're telling you to solve the following by factorization, they've already set up the problem so that the factors are going to be whole numbers. In real life, that's not always going to happen. In fact, most of the time it probably won't. But in this case, they want to see if you can factor, so let's factor. So the possible factors for 15 are 1, 3, 5, and 15. The possible factors for 12 are 1, 2, 3, 4, 6, 12. 12 is a popular one because it makes you work, right? And then we just need to figure out combinations here that are going to end up with negative 11x. And this is just kind of a, you just got to choose things and see if those work. So let's try first, I don't know, 3 and 5 for 15, right? Now, is there something that we can multiply? And like, obviously, one of these is going to be negative, one's going to be positive, but I'm just going to put both negative here just to see what happens. So here, let's put like 3 and 4. So if we multiply these together, we get 12. Multiply these together, we get 15. Doesn't look like any subtraction or addition we do on that is going to get 11. So no, we guessed wrong. So if it is 3 and 5 for this one, it's not going to be 3 and 4 there. What about 4 and 3? This will give us like 20. This will give us like 9. Hey, that kind of sounds promising, doesn't it? Because 20 minus 9 would be 11. Can we make that work? So this would be 4x, 3x. Now, we can see that since it's a negative 15 here, one of these is going to be positive, one of these is going to be negative. So let's just choose one. I'm just choosing randomly for now. So plus 3 times negative 5 gives us negative 15. 3 times 4 gives us 12. So far, so good. 3 times 3x would be 9x. Minus 5 times 4x is negative 20x. Oh, that was terrible. Handwriting. Okay, negative 11x. Hey, it worked out. Okay, so factoring is a challenge because there's not really a procedure that you can use that you'll be sure to knock it out in 90 seconds. It's like it's trial and error. So that's why in real life maybe we don't use it too much. Okay, so we can see that we found the two binomials that multiplied together are going to give us 0. And so now we just need to solve for each case. So if the first binomial, 4x plus 3, was equal to 0, that would make the whole thing equal to 0. So that's one of the solutions. The other solution would be 3x minus 5 equals 0. So let's find the x that makes each of these 0. So we just use algebra, and we get 4x equals minus 3. Divide both sides by 4. Now we get x equals negative 3/4. And I know you want to do this in your head, but you're going to end up sometimes getting x equals positive 3/4, sometimes you're going to get x equals negative 4/3, or something worse. So be careful. Write it out. We don't have to do too much algebra on the exam. Get in the habit of writing out your algebra and not losing a point for a careless mistake. So let's do +5 to both sides. And then we get 3x. The left side is just 3x. The right side is going to be 5. Divide both sides by 3. X equals. It's really hard to make a mistake in algebra if you write everything out like that. So these are the two solutions. X equals negative 3/4, x equals 5/3, and that's for that one. And that is page 1.